Hey guys, and welcome back. Thank you to Siyabonga for taking that question. It was such a great question. I don't love calculus graphs, but he handled it so well. He's making it so much easier for us to understand this stuff. For now, we have another question. It's the last question of the day, so make sure you send in your questions on calculus, guys. We have another week on calculus questions. So your cubic functions, differential calculus, whatever you need help with, send in your videos because we would love to help you out. For now, we're going to handle the last question of the day. It's from Masana. Sorry guys, got to check my notes there, went a little bit blank. Let's see what he has to say.
Hi Tenfold, my name is Masana. Could you please help me with these following questions?
Okay, so of course I get the graph question because I just said that I don't like graphs. But I'm going to help you guys. I'm going to help you to my best of my ability. It's actually a really nice question. It helps you understand how the first and second derivative relate to an original function. So let's just jump right into it. It says, the sketch represents the graph of y equals f prime of x. Okay, already guys, that should ring some serious bells in your head because that means that we don't have y equals f of x. We don't have the original function. We only have the derivative of that function. Okay. It also says that it has x-intercepts at -2 and 0, so there's that one there, and 0, 0. Lastly, it says the graph has a turning point at -1, -1, so that's that one over there. Okay. Before we get into anything in this question, guys, I want to make a note. We've been given that f prime of x, the first derivative, is a parabola. So that should immediately tell you guys that the original function that we differentiated to get to this one is a cubic function. You should also know that the second derivative of that first one is a linear function. Okay. So that's immediately what should ring bells here, guys. This is a parabola here, so that means that that first derivative comes from a cubic function. Okay, so now it says write down the value or values of x for which the tangent to the graph of f is horizontal. Note that they mentioned the original graph, guys. This one here, not the graph that we're given, not this one. It's of f. Okay, it says write down the values of x for which the tangent to the original graph of f is horizontal. Okay, so when we talk about horizontal lines, guys, we should immediately know that that means that the gradient of that function is equal to 0. Okay, guys, remember, if we have a horizontal line, it means that it's lying like flat like this. And the change in y over the change in x, there is no change in y. So that means that the gradient is going to be 0. There is no change. There's no rise over run. Okay, so if we're looking for a horizontal tangent, it means that the gradient of that tangent is 0. Okay. So, the second thing we can say about this, when we look at the derivative of the original function, that gives us the tangent to that function at specific points. So what we're looking for here essentially is where the gradient of the tangent or the derivative of the original function is equal to 0. Okay, so luckily enough for us, we were given that where it's equal to 0, the y value is equal to 0, at x points, -2 and 0. So we have x is equal to -0 or x is equal to 0. Okay, easy peasy, because we're going to have this cubic function here. At x equals -2, there's going to be a horizontal tangent, and x equals 0, there's going to be another horizontal tangent. Okay, let's move on to the second part. It says, draw a neat sketch of y equals the second derivative of f of x. Okay, so remember what we said, that is a linear function. Okay, so here we simply need to derive or find the second derivative of the original function. So we find the derivative of this function here. So we have the turning point. So remember, that is given to us by x minus h squared plus k, where these are the coordinates of the turning point. So to find the equation of our parabola, we simply substitute in some values. Okay, so I'm going to choose the point -2, 0. So the y value is 0, x value is -2, the turning point was given to us as -1 all squared, and the y value of the turning point is also -1. Okay, so let's simplify this out. We get a into -2 plus 1 is -1 squared minus 1. So we get 0 is equal to a minus 1, therefore a is equal to 1, which makes sense because it's concave up, guys, which means that a is positive. So y is equal to just x plus 1 squared minus 1. So now to derive this, we need to multiply out that bracket, so we get plus 2x plus 1 minus 1. So the equation of the parabola, guys, that first derivative of the original function, is just x squared plus 2x. So if we want to find the equation of that function, we derive and we get x squared plus 2, or 2x plus 2. So if we want to draw that function, easy peasy. It's going to intersect the y-axis at 2 and the x-axis here at -1. Draw your line through there, and that is the second derivative. Okay, easy peasy lemon squeezy, guys. Hopefully you've loved these questions that we've done today. I've actually really enjoyed doing the graph functions, which I don't love doing. Hopefully you guys are feeling a little bit more comfortable with calculus. I know sometimes it's a little bit scary for you matrics. It's really not one of the favorite subjects in matric, so we're focusing a lot on it, guys. We have another week after this one focusing on calculus, so we'd really love to give you some help in your calculus questions. Thereafter, we're going to move on to analytical geometry, so if you feel like you're struggling a little bit, download the app, send in the videos. Thank you once again to Liberty for sponsoring both our show and our app. We couldn't have done it without them. We couldn't do this without you guys. You are our number one. You're our top priority, so we love being here. So tune in, guys. Tomorrow, same time, same place. We will be back with another fantastic show for you guys. But for now, that's it for this show. Hopefully you had a lot of fun, and we will see you tomorrow. Bye.